Hello students, how are you? I hope you are doing great. So as a continuation of topic 6 sound, today we are going to discuss about pitch and volume. These are two properties of sound. Before that, we will have first our review. Yuri is playing a drum like this. Now we have the following questions. For letter A, you have to explain how the drum makes sound. For B, Yuri can hear the sound. Describe how the sound travels from the drum to his ears. And for C, you have to complete the sentence. Sound travels in the form of blank. You may pause the video to give you time for answering. For the answers, we have for letter A, the skin of the drum vibrates. Now remember the keyword vibrate. So whenever we are going to explain how something makes sound, then you have to include the word vibration or vibrate, because this is the reason why these things are creating sounds, because of the vibration. Now for letter B, Yuri can hear the sound. Describe how the sound travels from the drum to his ears. So it will start from the source, which is the drum, right? So the sound travels from the drum, which is the source, to the air, then into his ears. So that means the vibration will start from the drum, and then it will be passed on to the air particles that surround the drums, and then it will go into his ears. For letter C, complete the sentence. Sound travels in the form of, the answer, wave. Did you get all the answer correct? If yes, then you are doing a great job. Next one, we have below is a sound wave, and some of the parts of the sound wave are labeled. For letter A, you have to name the labeled parts. For B, what is frequency? So that means you have to give the meaning of frequency. And for C, which part of the wave shows the amount of energy the sound has? So pause the video to give you time in answering. For the parts of the wave, we have A, B, C, and D. So let's start with A. So what do you think is the name of this part? Did you say crest? Then you are correct. Now for B, we have trough. And then for C, it's wavelength. And for D, we have amplitude. Now for question B, what is frequency? So when we say frequency, remember that we are talking about the number of waves in a given time. So how many waves does the sound has in a given time? That means for 1 second, for 2 seconds, or for 1 minute, and so on and so forth. Then for letter C, which part of the wave shows the amount of energy the sound has? So is it the crest, the amplitude, the wavelength, or the trough? The answer is the amplitude. So the amplitude, which is the height of the wave, it shows us the amount of energy the sound has. Did you get all the answers correct? If yes, then again you are doing a good. Okay, to start with our new lesson, I want you to first observe the two sound waves here in the screen. We have A and B. Now, I want you to take note if there is any similarity or difference between the two waves. We have A and B. I want you to focus on the wavelength and the amplitude of A and B. Compare them. So to start with, let's compare the amplitude. Okay, the amplitude of A and the amplitude of B. Are they the same or different? Actually, the amplitudes of A and B are the same. So if you are going to measure the height of A or the amplitude and then of B, so they are of the same height. So that means A and B has the same amplitude. Now let's go to the wavelength of A and B. Are they also the same or different? They are different. The wavelength of A is shorter than B. So if we are going to take the wavelength of A, this is the wavelength, and then of B, so there is a big difference, right? So A has a shorter wavelength and B has a longer wavelength. So those are the similarity and difference between A and B. Now based from that, which one, A or B, has more waves? Is it A or B? Obviously, it is A. So A has more waves, right? So what is again the term or word that refers to the number of waves in a given sound wave? We have frequency. Okay. Now frequency, it depends on the how long or how short is the wavelength. If it has a shorter wavelength, that means that it will have more waves, and then if it has a longer wavelength, then that means it will have less number of waves. Now I want you to remember that more waves means higher frequency, and higher frequency means the vibrations are faster. Do you understand? Okay. Next question. Which wave is a high sound and which wave is a low sound? So we have the same sound wave, A and B. Now, A is a high sound. How did we know that? Because it has more waves. That means it has higher frequency. That means it will have faster vibrations. So it will be a high sound. Then B is a low sound because it has less number of waves. That means it will have lower frequency because the vibrations are slower. And that's for the low sound. So when we talk about high sound and low sound, we are talking about the property of the wave. And this property is known as, you have pitch. So pitch is a property of the sound that refers to how high or low the sound is. Now to give you an idea on how this high sound and low sound sounds like, so I have here a guitar. Okay, so I will pluck the string and then starting with the low sound and then to the high sound. So let's start with the low sound. Again. Okay, so that is a low sound. So that means the string is making less wave and the vibration is slower. Now how about the high sound? One more time. So that is a high sound. That means the string is making more wave and then the vibration is much faster. Okay, so this is a low sound. And this is a high sound. Application. Study the sound waves below. We have A, B, C, and D. For the first question, which sound has the highest pitch? So which do you think it is? It is A, B, C, or D? Now remember, you need to look on the size of the wavelength. Okay? So that means the shorter the wavelength, then that means the higher the pitch. If it has a longer wavelength, then that means it will have a lower pitch. So when you say which sound has the highest pitch, that means which one has the shortest wavelength. Is it A, B, C, or D? The answer is B. Okay, so that means B, if we are going to compare with A, C, and D, its wavelength is the shortest. So therefore, it will have the highest pitch. Now for B, which sound has the lowest pitch? It will be, we have D, because it has the longest pitch among the four. Then for letter C, which sounds have the same pitch? Have A and C. So if we are going to compare the wavelength of A, B, and C and D. So here is for B, so it has the shortest, then D has the longest, and then for A and C, the same wavelength. Now remember, when we say pitch, we are talking about how high the sound or how low the sound is. And in order for us to identify whether the given sound wave has a high sound or a low sound, then you have to look on the length of the wavelength. The shorter the wavelength, the higher the sound. Then the longer the wavelength, the lower the sound. To continue, I have here another set of waves. You have A and B. Now I want you to compare the wavelength of A and B. Are they the same or different? They are the same. So here is the wavelength of A and here is for B. So if you will notice, they have the same length. Okay. Now next, how about the amplitude of A and the amplitude of B? The same or different? They are different, right? If they are different, which one has a longer amplitude and which one has a shorter amplitude? So the amplitude of A is longer than B. Now based from that, so that's the amplitude of A and B. So it is obvious, right, that A has a longer one. The next one. Which one, A or B, has more energy? We have. Now, always remember, as we discussed the amplitude in our previous lesson, amplitude shows us the amount of energy the sound wave has, right? So if that is the case, which one do you think has more energy? Is it A or B? The answer is A has more energy. What do you think is the reason why A has more energy? Because it had longer amplitude. So that means it will have more energy. And if we are talking about the energy of the sound, then we are referring to how loud the sound is, right? And the word that refers to the loudness of the sound is known as volume. Now, the volume of the sound refers to how loud or soft the sound is. Or in short, it refers to the loudness of the sound. Now, this volume is different from the volume of matter, because the volume of matter refers to the space that is being occupied by an object, but the volume of refers to the loudness of the sound. Now, based from this, remember that the longer the amplitude, excuse me, will have more energy, and if it has more energy, that means the vibrations are large. So which means which wave, A or B, is a loud sound and which wave is a soft sound? A is a loud sound because it has longer amplitude, it has more energy, then it has large vibrations. That means loud sound. And B is a soft sound because it has shorter amplitude. That means it has less energy, small vibrations, soft sound. Now, to give you an idea on how the loud sound and soft sound sounds like, so again, I have here the guitar. Okay, now this time I will not change the pitch. Okay, so let's use first a low sound, and then we're just going to change the volume, meaning the loudness of the sound. So here is the first sound. And here is the second sound. Again, the first sound. And the second. Now, which one is the loud sound? Is it the first or the second? It is the first. So therefore, the second sound has a soft sound. Now, let's use a high pitch sound, and we're just going to change the volume. First sound. Again. That's the first sound. Again. Okay. Now, this is the second sound. Again. So compare the volume of the first sound and the second sound. So which one is a loud sound and which one is a soft sound? It is the second. Okay, so that is volume. Refers to how loud or soft the sound is. Application. I have here the same four waves, the same as a while ago. We have A, B, C, and D. Now the first question is, which sound has the loudest sound? Now this time, don't look on the wavelength, but rather look on the amplitude of the sound. So loudest, that means it has the longest amplitude. So it will be D. And then which sound has the softest sound? Okay, so the softest will be having the shortest amplitude. It will be A. Then which sounds have the same volume? It will be B and C. So if you are going to observe the amplitude of the loudest sound, that's the amplitude, and we are going to compare it with the softest sound, which is A, okay, and then this is the amplitude of C and the amplitude of B. Now remember, when we talk about volume, it refers to how loud or soft the sound is. And in order for us to identify whether the given sound has a loud sound or a soft sound, you have to look on the height of the amplitude. So tall amplitude or long amplitude has a loud sound, while short amplitude has a soft sound. To sum up what we have learned today, here is a mind map or a concept map. So we talk about today about the two properties of sound. And these two properties are pitch and volume. The pitch of the sound depends on the wavelength or the frequency, while the volume of the sound depends on the amplitude or the amount of energy the sound has. And when we talk about pitch, we are going to use these two words, high or low. Okay, so this is a high sound and this is a low sound. And then for volume, we are going to use the words loud and soft. That means changing the amount of energy that we apply on the object that is making the sound. So this is a loud sound. And this is a soft sound. Okay, now always remember these four words: high, low, loud, soft. So when we talk about high or low sound, we are talking the pitch of the sound. And when we talk about loud and soft sound, we are talking about the volume of the sound. So that's it for today. Thank you for listening and have a nice day.